Now in class 12th, I am taking the potential gradients. I have told you about the construction and the principle and working of the potentiometer, and now I will discuss about the potential gradient. विभव प्रवणता, इसको हिंदी में विभव प्रवणता कहते हैं. So now first let us I will make the circuit diagram of this one. Now here we have the circuit diagram of the potentiometer. Now here we have that let E naught equal to EMF of battery in main circuit. So this is the main circuit. Main circuit. This is now auxiliary circuit. Auxiliary circuit. And E equal to EMF of primary cell in auxiliary circuit. So there are always two circuits in the potentiometer, one the main circuit and second the auxiliary circuit. The main circuit never changes. Whatever change that whatever you want to measure, that is only in the auxiliary circuit. And let L equal to length of potentiometer wire AB, R equal to resistance of wire AB. Now then, as I have told you that the potential drop current length of the wire is called the potential gradient. When current from main circuit is passed in wire AB, there is potential drop along the length of wire in. This is what that usually happen. But when we take the potential drop per unit length, then this is called the potential gradient. The potential drop per unit length of wire AB is called potential gradient denoted by X. So this will be how much? The EMF of the cell divided by the resistance of the wire. Resistance of the wire. So now this X equal to E naught upon A, because current is coming from this main circuit. So we have to take the EMF of this battery. E, that is not E naught. E naught upon L. L is the total length of the wire. So you can have this is equal to your I into R upon L. This E naught is equal to I into R. I the current that passes through the wire, R the resistance of the wire. So potential drop will be, this will be how much? I into R. This I is equal to, again we can write it, this is your E naught upon R plus R dash into R upon L. This is equal to X. This is one formula. Now that we know that the resistivity, we know that resistivity rho is equal to R A upon L. So R upon L, this is now your rho upon A. This is equal to R upon L. So in place of R upon L, we can write down this, the value of rho upon A. So in place of here, what can we write? Therefore, now this X is equal to I into rho upon A. A is what? Cross sectional area. This is now pi r square. So what we have? This is I into rho upon pi r square. This is equal to X. This is one more formula. So now we are having this formula, this formula, this formula. So these are the formula of this X. Now here this capital R the resistance of the potentiometer wire, R is the internal resistance of cell, R is the resistance of the rheostat. So what we have here? Where R equal to internal resistance of cell and R dash equal to resistance of rheostat. Resistance of rheostat. We have considered whole of this circuit. Internal resistance of this battery, resistance of this rheostat, and resistance of this wire AB. So this is what we have taken to this X equal to so much. Here there is no concern in this auxiliary circuit, because we have to take only the potential gradient which is associated with the main circuit. So this is what that we are using the notations of the main circuit. Here this R upon L, that we have taken this rho upon A is the area of cross section of the wire, that is equal to pi R square. So what we have the conclusions of this one? Therefore, the potential gradients depends upon following factors. What are these factors? Now first we take from here. This we take. This is I rho upon A. Number 1. X is proportional to I. Current I. X is proportional to R. The resistance of the wire. Resistance of wire. L. X proportional to 1 upon L. Larger the length, less is the potential gradient. It depends upon E naught. Second, X proportional to what? This E naught. And then X depends upon this R and R dash. X depends upon R and R dash. Now this third, this X proportional to rho, the resistivity. This X proportional to 1 upon R square. There are so many factors. R. This R is the radius. This you have to remember. Oh, pi is R. So what to write to this one? Then this is to be RS. Pi R is the internal resistance. This I have taken just to differentiate this R and this R. This is the internal resistance R dash. This is the radius of the wire. R the radius of the wire. Radius of wire A. And now if we suppose if r dash equal to 0 and r dash equal to 0, हम ये मान लें कि भाई जो बैटरी का इंटरनल रेजिस्टेंस है वो 0 के बराबर है और रियोस्टेट का रेजिस्टेंस है वो भी 0 के बराबर है, तो ये क्या रह जाता है रेजिस्टेंस फॉर्मूला, देन x इक्वल टू, इसमें देखो आप इससे नाउ फ्रॉम हियर दैट वी ड्रॉ फ्रॉम हियर, so this is equal to E naught upon R into R upon L. So what we have, this R and R will cancel, so x equal to E naught upon L. This is not so much. That in this situation, when the potential, when this internal resistance of the cell and resistance of the rheostat is taken to 0, the potential gradient does not depend upon the resistance of the wire AB, as we have said here, x proportional to R. This is not so. So in this condition, x does not depend upon R, the resistance of wire AB, then it depends upon the length of the wire. So just to minimize the minimum the potential gradient, maximum is the sensitivity that is related with this sensitivity. So to have the minimum potential gradient, the length of the wire must be maximum. For minimum value of x, the length of wire by AB must be more. For minimum value of x, the length of wire AB should be maximum. Should be maximum. This is why that meter long wire is taken. तो कभी कभी पूछते हैं कि भाई 10 मीटर लंबा तार लेते हैं तो क्यों लेते हैं इसको, इसकी लंबाई इसके जगह पर हम 1 मीटर क्यों नहीं ले सकते, 2 मीटर क्यों नहीं ले सकते, ले सकते हैं, नो प्रॉब्लम. You can take 1 meter, 2 meter, 3 meter, 4 meter, 10 meter, 100 meter, whatever you like. The larger will be the value of the length, the less will be the potential gradient. So this is for the benefit of the instrument, and also you will measure more and more accurate values if the potential gradient is minimum. So to have the minimum value of potential gradient, we take the maximum length of the wire. Generally, some of the students may ask that if suppose we take the 100 meter of wire, then what is difficulty? Difficulty is that the potentiometer will be so large that it will be difficult to handle the instrument when this is used for the measurement of the potential difference or the EMF of the cell. So just to have the easiness for the practical purpose, the length of the wire is taken approximately 10 meter. This is one of the most good question for the asking that why the wire is taken to be 10 meter. In some of the potentiometers, the wire is taken less than 10 meter, it is of 3 meter, 4 meter or 5 meter, then there is no difference. But the values, whatever we measure, that will not be so good as this is measured by a long wire, approximately of 10 meter. So this is why that a 10 meter long wire is taken. So for minimum value of x, the length of the wire AB should be maximum. This is why that 10 meter long wire is taken. So for the better measurements by the potentiometer, the potential gradient must be minimum. For better measurement, by potentiometer, the potential gradients must be minimum. This is why that we take to this one. So this is about the your potential gradients of the potentiometer. So thank you very much.